What's up, everybody? This is the green packet, Unit 10, 10.4. I believe this is page 17. Today's learning target is I can find the area of trapezoids, rhombi, and kites. So last time we learned about the properties of those three, and now we're going to actually talk about how to find the area of those types of shapes. Really not too bad of a day. It's kind of just, I'm going to give you some formulas and you're going to plug stuff in. Not too bad. So let's talk about trapezoids. The area of a trapezoid, here's the formula for that. Let's talk about what these mean first, though. H, you might guess, stands for height. Okay, so we're going to plug whatever we get for the height in right there. And then in parentheses, it's going to be important that we add up the bases. So if this is base 1 plus base 2, we're going to add those up inside the parentheses, and then we're going to divide all of that by 2. It looks kind of crazy, but it's really not too bad. These are the bases also, by the way. So these are the bases. So in our picture, as you can see, the bases are parallel to each other. So let me kind of show that to you. If this is a base, that's going to be base 1. And then base 2 has to be parallel to base 1, right? That could be represented by arrows. Okay, they don't touch, right? They go the same direction, and they never touch. And then finally, the last, oh, sorry, I could highlight B2. So those would be what you'd plug in there. And then the height is always at a right angle with the bases. Okay, it goes up and down. All right, that's about it. So let's just kind of hop in. Let's use that formula. I think you learn best by just doing right here. So let's take a look at this first example. We have a trapezoid. Okay, we have a trapezoid. We know it's a trapezoid because these two are congruent. Here's our formula. Area equals H B1 plus B2 divided by 2. So let's just go ahead and plug stuff in. I know there's not a ton of space, so try to write as small as you can. Here's how I would start this. A equals, okay, what is my height here? Well, going up and down is 6. That's my height. This would be my base 1. This would be my base 2. Okay, make sure you know how to do that according to our picture. I just labeled it exactly like my picture up here. Okay, height goes up and down. Base 1 and base 2 are parallel to each other. Okay, then I just start plugging in. So if H is 6, I'm going to put 6 right here. And then in parentheses, I'm going to have B1, which is 7, plus B2, which is 10, all divided by 2. Okay. Okay, if you're a color person and need to see this, this is 6. Okay. Base 1 was 7, so I plugged that in right there. Base 2 was 10. Plug that in right there. Okay? Nothing too crazy. Now, I would kind of just get out a calculator at this point for this. Take a look at what's going to happen here. Okay. Here's what I would do. I would first find the top part. I would write it exactly the way I see it. So I would do 6 and then in parentheses 7 plus 10. I would write it exactly the way I see it right there. Then I would divide all of that by 2. Divide all of that by 2. 51. Let me do that again. 6 and then in parentheses 7 plus 10. Remember, you're not multiplying those together. You're writing it exactly the way you see it. And then you need to divide that by 2. So whatever number I just got, I'm going to divide it by 2. And I should get 51 there. 51. Okay, so the area of that trapezoid is 51 units squared, or we don't have units, but it would be something like that. Okay, 51. And guys, that's about as crazy as it's going to get. Okay, there's going to be a little bit of variation every now and then, but that's basically the idea. Okay, so let's take a look at this one. You're like, Mr. Colston, I see a line right here. I see a line right here. They're both parallel to each other. But the height is going sideways. And you're like, what the heck? Well, if you flip it over like this, doesn't that trapezoid look exactly like what we had over here? Same thing, right? So in other words, the two lines that are parallel, those have to be our two bases, right? So let's make sure we're on the same page. This would be base 1, right? That would be base 1 because it is parallel to base 2. I would probably call the smaller line base 1 traditionally, and the bigger line base 2, just to stay consistent. And then finally, the height here would be 4 root 3. 4 root 3. Okay, that's our height. All right. So if we take a look at this picture, let's see what we know so far. Well, we know A equals, our height is going to be 4 root 3. I know that looks ugly. Just write it down. Don't think about it. Height is 4 root 3. I know that looks ugly. Just write it down. Don't think about it. Okay, what is base 1? Base 1 is 5. Okay, see how I'm just plugging it in. Plus base 2. So let's think about it for a second. Okay, remember base 2 needs to represent the entire length from this tip all the way to this tip. So look at your picture. Take a good look at it. Okay. 8 represents just this part right here. Let me visualize that a little bit better. 8 represents from the tip to the angle right here, right? From the tip to the angle. 4 represents the remainder. So hopefully you see visually that the entire distance of B2, the entire distance, is not just 8. Guys, it's not just 8, but it's also not just 4. It's 8 plus 4, which is 12, right? Okay, so this entire distance, this blue part, is actually going to be 12. Okay, so visually, this is my height, right? This is my height. This was B1. That makes sense. And then B2, I had to add those two numbers together. So sometimes it's going to be a little bit tricky like that, but you can handle it. All that's going to be over 2. Okay, so again, let's go to the calculator. Let's write just the top part first. Okay, that's how I would do it. Again, you don't have to do it exactly like I'm doing it, but I think this just keeps it simple. So I would do 4. Remember, control x squared would give you root 3. Let me show you that. 4 and then control square root right here. 4 root 3. And then scroll over a little bit. Okay, so that's your first part. That's orange. And then in parentheses, 5 plus 12. Okay, that's that part. I'm going to divide all of that by 2, and I'm going to get 58.8897. Okay, I'd probably just round that to area equals 58.9. That's probably what I would call that. Area equals 58.9. Okay, so let's pause for a second. I know you kind of think that was probably pretty wild. Let's just make sure we're on the same page. The height was still pretty simple to find. It's the thing in the middle. It's the dotted line. The base was easy to find, base 1. Base 2, remember we had to add those two together. So if you need a refresher, maybe watch that one again. That one kind of got crazy. So just be on the lookout. All right, let's take a look at this one. This one is a little bit different because it is not what we call an isosceles trapezoid, right? But the deal is this formula always works for any trapezoid. It doesn't matter if it's isosceles or not. This will still work. So maybe it would be helpful if I color-coded it first. Okay, the shorter base is this. Okay, it's parallel to this base on bottom. All right, so the yellow is going to be base 1. The blue is going to be base 2. Okay, what about the orange? Well, the orange is this height right here. Okay, so we're still have to figure that out. Okay, so we need to figure out the height. Base 1 is going to be the yellow. Base 2 is going to be the blue. So let's take that one step at a time. One step at a time. The area equals, okay, what's the height? Well, if you zoom in, right, let's take a look at what this height is. We're looking for a distance. Okay, so the height right here is this measure, this orange line. Okay, it's not going to be 30 degrees. That's an angle measure. Okay, it's not going to be 3.5. It's not going to be 7. 7 is the distance right here. That's the hypotenuse of that little right triangle right there. The height is actually going to be 6.5. Okay, so let's process that for a second. This orange line is the same distance as this line. So this would be 6.5. The height is actually going to be 6.5. Make sure you're okay with that. Okay, what about our first base? Well, our first base is pretty simple. It just tells us it's 9. That's easy. Okay, what about our second base? Okay, if you look, we're trying to find this entire base. So let me mark that. I'm trying to find this entire base. Okay, the entire blue line. Is the entire blue line represented by just 3.5? No, 3.5 is just that little sliver right there. Well, is our entire blue line represented by just 9? No. But here's what we do know. If this yellow line is 9, I bet that part right there is also 9. Okay. Just like this was 6.5 and this was 6.5, this is 9 and this is 9. Okay, so B2 would technically be equal to 9 plus 3.5, right? Which would be 12.5. Okay, so pause for a second. Make sure you're okay with that. If you need to rewind that, do it. This should be 9 plus 3.5. That represents the entire blue thing. 12.5. All over 2. So now let's see what happens when we put all that in the calculator. Okay, I'm going to zoom out a little bit. Okay, so we would get 6.5. I would put 9 plus 12.5 in parentheses, click enter. So I'd put all that in parentheses, and then I would divide that number by 2, and I would get 69.875. I'm going to round that to like 69.9 units. Okay, on the homework we'll be clear, or your teacher will be clear about how much rounding to do, but that should get you started. So that's kind of the basics, guys. It's basically just a formula. Okay, don't overthink it. All right, let's talk about example 1. This one's different because it doesn't give us a picture, right? So we have to actually draw this picture out. All right, if a trapezoid has a height of 5, so let me draw a trapezoid. How about I draw it right here? Here's my little trapezoid. Give yourself some room. Don't make it too big. Here's my trapezoid. Okay, if my trapezoid has a height of 5, all right. Height of 5. Okay, that's what my height looks like. Doesn't that look a lot like what we were doing up here, right? Height of 5, a base of 6. Okay, I've already put this base is 6. Okay, an area of 48 units. Let me write that down. Area equals 48. I'm going to find the other base. So what is base 2? Okay, so let's pause for a second. Here's your picture. If you haven't written that down, I would write that down. Let's really talk about this. So, in this situation, here's what's different. First of all, we had to draw the picture. Second of all, it has given us the area. If you take a look at these other things, we actually had to find the area ourselves, right? On this one, it has given us the area, and we actually have to find one of the bases. This is a little bit different. Let's talk about what this is going to look like. We're still going to use the same formula. So let me walk you through step by step. Area is still going to equal h b1 plus b2 over 2. So write that down. Pause the video if you need to. You need to write that down. We're going to start plugging in what we know. Okay, so this is the height. That's the height. Okay, this is base 1. Base 1. And then this is what we're looking for, base 2. Okay, so let's start plugging stuff in. We also know the area is 48. So if we know the area is 48, I can say A, instead of A, I'm going to write 48. Okay, just because it's the area doesn't mean we still can't plug it in like we were doing before. What is H? 5. Okay, what is B1? 6. Plus B2. We do not know what it is, so let's just call it B2. All over 2. Whew. Getting kind of crazy, huh? Kind of crazy. So in this situation, guys, here's what we have. We do not have something we can put in the calculator yet, unfortunately. We have a situation where we actually need to solve for B2. This is an equation that we're solving for. Okay, so we need to get B2 by itself. All right, when we're doing that, let's think through kind of our strategies. Okay, you want to do multiplication and division before you ever do addition and subtraction. So when I see this problem, the first step I would do is I would multiply both sides by 2. Multiply both sides by 2. Okay, what that does for me is that 2 on bottom and that 2 on top are actually going to cancel each other out. Hopefully that feels pretty familiar to you. Let's keep going. This would be 96 equals 5 times 6 plus B2. So let me rewrite that over here. 96 equals 5, 6 plus B2. Okay, we're going to keep solving. All right, in this scenario, what I would do next, I know there's some different ways you could solve this. You could distribute this 5, for example. You could run with that route, and that'd be perfectly fine. What I would do is I would actually divide both sides by 5 here. Divide both sides by 5. Let's see what we get. 96 divided by, 96 divided by 5. Let's see what that is with decimals. I know this is getting kind of crazy, but that's going to be 19.2 equals 6 plus B2. Okay, that now is a very simple equation. I know it looks crazy with the B2, but you subtract by 6 on both sides, and that's your answer. So I'm going to get, I believe, B2, or sorry, let me write that slightly different. We'd get 13.2 equals B. So let's say B equals 13.2 units. B2. Okay. So let's just pause for a second. Let's take a deep breath and kind of look at what we just did. The only difference here is that it gives us the area, so we have to use this formula to actually find one of these measurements. Kind of funky, but take a look at the picture. Doesn't 13.2 just kind of make sense? Doesn't that just sound like a pretty good number, right? Now let me show you real quick how you could actually check your work here. All right, if this is our formula, right, what we could do is we could actually check our work. So we could do 5 and then in parentheses 6 plus, now we know B2 is 13.2. Let's see what we get there. Divide that number by 2 and we get 48, which was our area. So basically what I just did is I can re-plug in this number for B2 in order to see if it still equals 48. Okay, guys, don't sweat about that one too much. That one's on the harder side. Let's take a look at example 2. This one's also kind of on the harder side, but we can do it. Okay, example 2. We are trying to find the area. So let me write that down. Find the area. Find area. Okay, so as you can expect, we are going to be using this formula. Area equals H B1 plus B2 over 2. Okay, so let's start plugging stuff in. We know the height is right here, but we don't really know that height yet. Bummer. Okay, what else do we know? We know that this is base 2. We know this is base 1. So we know this should be base 1. We know this should be base 2. That seems pretty simple enough. So this would probably be equals, this would be base 1. This would be base 2. Okay, H is going to be, we don't know that this is the measure of 5, so we actually don't know that. But we do know that this is 8 plus 14. That's what we know so far, all over 2. Okay, so let's talk about how we find this orange line, right? Here's our situation. We know that this measure right here is 5. We know Maybe this little measure, we could probably figure that out, but we don't know the orange line. So let me redraw this triangle so we're on the same page. Here's a right triangle. Okay. We know this is 5. Okay, we're trying to find this one. We're trying to find this. This is h. We're trying to find h. Now we need to know this side in order to find h. Let's talk about how we find this part. You should hopefully see how the yellow line is 8. This part's 14, right? These are symmetrical. This is an isosceles trapezoid, which means this. If I were to draw another dotted line right here, okay, this line right here has to be congruent to this line. Okay, so stay with me. This part right here has to be congruent to this part. That's the bottom line. So if this yellow is 8, this part right here has to be 8. Okay, and if this, from this part to this part, that's 8. Okay, let's talk about how we would find these two parts. These two parts have to add up to 14 minus 8. So 14 minus 8 equals 6. So that means that these two parts have to add up to 6 at this point. 6 divided by 2 would be 3. So this part has to be 3, this part has to be 3. Okay, at this point we know that this side of that triangle is 3. Okay, we can use a squared plus b squared equals c squared in order to figure out the height at this point. So let's do that real quick. This has to be c because that's my right angle, a and b. So I could do h squared plus 3 squared equals equals 5 squared. H squared plus 9 equals 25. Subtract by 9 on both sides. H squared equals 16. Divide both, or find the square. H is going to equal 4. So what we just learned is that this height right here is actually 4. Using the Pythagorean theorem, more or less, that's what we just did. Height is 4, so I can plug that in. So if you need to rewind that, do it. There's a lot that just happened right there. But essentially, we now know that the height is 4, and we can just plug into a simple equation. So let's see what we get. Let's see what we get. So 4, 8 plus 14 divided by 2, you'd get 44. So the area of this trapezoid is 44. All right? So again, these two at the bottom are pretty cray, but if you need help, I would ask your teacher. I would also rewind the video to kind of catch and see if you feel good about that. Okay, it takes a couple times maybe to watch it. All right, let's move on to page 18. We're going to talk about rhombi and kites. They have the same formula. Okay, the only difference between a rhombi and a kite is the fact that rhombi always have these are all congruent. Kites, these two can be congruent and these two can be congruent. But it's the same formula, so you don't really have to worry about it. Okay, here's our formula. Area equals d1 times d2 over 2. So very simple. These are called the diagonals. Okay. These two are called the diagonals. And the order does not matter. The order does not matter. Okay? So basically, if you look at your picture, the diagonals are what's going across. So D1, right there, it crosses D2, right there. Okay, same thing in this picture. D1 goes across, crosses D2. Okay, the important thing here is it's the entire distance. So it's from one corner to the next. One corner to the other, one corner to the other opposite side. One corner to the opposite side. It's not just like this part right here, it's the whole distance. It's not just this part right here, it's the whole distance. That's the main thing. Other than that, it's really not too bad, guys. Okay, So what you're going to do is you're going to multiply those two diagonals together and multiply by 2. Okay, let's take a look at an example. All right, here's our formula. Area equals d1 d2 over 2. Let's plug it in. Area equals, I could call this a diagonal, and I could call this a diagonal. Okay, so let's figure out what d1 is going to be. Let's figure out what d2 is going to be. All right, take a look at d1. The entire yellow line is not just 4. Okay, so if I were to write 4 there, that would be incorrect. It's not just 4, it's 4 plus this 4, which is 8. So the entire distance right here is 8. Right? Okay, what about the blue? So I have 8 right there, and then the blue is not just 6, not just this 6, it's 6 plus 6. So the entire distance here is 12. 12. So 8 times 12 divided by 2, actually pretty simple. 8 times 12 divided by 2, 8 times 12. Again, I would do the thing where you just kind of multiply the top and then divide it by 2. 48. Okay, area equals 48. Okay, guys, don't overstress it. If you need to rewind that and watch it again, do it. What about this one? Remember, the diagonals do not matter in terms of order, but I'm just going to highlight a couple so you know which ones I'm talking about. I'm going to say this is the yellow. I'm going to say this is the blue. Remember, it does not matter. If I would have done 12 times 8 over here, it would not have mattered. Okay, let's try to find the measure of D1, the yellow. It's not just 4. It's not just this 4. It's 4 plus 4, which is 8. Okay. What's the D1? It's not just 7. It's not just 3. It's 10. Okay, so visually, let's make sure we're on the same page. This is 10, right, because it goes the whole distance. This would be 8. Okay, so I would do 8 times 10 divided by 2. That's actually pretty simple. It would just be 40. All right. All right, now this one gets a little bit crazy, but we got this. Here's what we know. We know the perimeter is 20. The length of one diagonal is 8. Oh dear. All right, let's see if we can do this. The perimeter, what does that mean? Okay, it means all the sides added up. Okay, well, according to our picture, we know that this is actually specifically a rhombus. Let's talk about how we know that. Okay, remember rhombi, all of their sides are congruent. All of their sides are congruent, right? So here, all of our sides are congruent. That's helpful to know. The reason they're telling us that the perimeter is 20 is because we need to know the measures of these sides first. Okay, so if the perimeter is 20 and all the sides are the same, I can do 20 divided by 4 to equal 5. Okay, so let me pause that and make sure you're okay with that. If all of the sides add up to 20 and I want to know the measure of 1, they're all the same, just divide by 4. So this is 5, this is 5, this is 5, this is 5. Okay, now what else do we know? Well, we know the length of one diagonal is 8. Doesn't matter which one we pick. How about we study this one? So the length of that whole diagonal is 8. Okay, well, how does that help us? Well, if we now know that this whole thing is 8, that could be cool. That could be good to know, right? We know diagonal 1 is 8. Cool. But we do not know the measure of the other diagonal, do we? Okay. We do not know the measure of the other diagonal. So I'm going to tell you kind of how we do that. It's going to get kind of crazy. Hang with me. Okay, we're trying to find D2. So if we know that this entire diagonal is 8, right? With rhombi, we actually know that this is going to be 4 and this is going to be 4. Okay? That is helpful because now we see we have a right triangle. So let me redraw that right triangle over here. We have a right triangle. This is 5, this is 4, and it would be helpful to know that distance right there. Well, guys, this is an a squared plus b squared equals c squared type of thing. right? I could go through that whole process, but let's remind ourselves of what we just did on the previous page. We had a triangle that looked exactly like that. We had 5, we had a 3, and we were looking for the third one, which was 4. This is what we call a 3, 4, 5 right triangle. So this is actually going to be a 3, 4, 5 right triangle as well. So I know this distance right here is 3. Let me just prove that to you real quick. This would be 5 squared equals 4 squared plus b squared. Subtract 4 squared on both sides. You get b squared equals 25 minus 16, which is 9. B equals 3. Okay, so if we know that b is 3, we now know that this other part is 3. I know it gets crazy. But now we know the entire diagonal is 6, and we have the information we need. All right, so if we go back to the formula, let's take it one step at a time. Area equals the diagonal 1. It's the yellow. We knew that was 8 from the get-go. That part's not hard. What about diagonal 2? It's the blue part. We figured out this part's 3, so this part has to be 3. So 3 plus 3 is 6. Divided by 2. Area is going to equal 24 units squared, basically. Okay, don't freak out. Maybe go rewatch the video if you need to. That's how you do that one. All right. What about this one? Very similar to what we did on the other page. We have to draw the kite. Okay, so if a kite has a diagonal of 6, let me draw this little kite. Okay, there's our kite. Boom, 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 boom. Okay, so we know that one of the diagonals is 6. I could label it like this. One diagonal is 6. The area is 48. What is, let's say this is D1. What is D2? Okay, so we know D1 6. We know area is 48. Guys, we got everything we need. Let's just hop in. So what's diagonal 1? We know it's 6. So in other words, this diagonal right here would be 6. Okay. Boom, easy peasy. What about our other diagonal? We don't know it. Let's just call it D2. We know this is all over 2. Okay, what was our area? 48. So essentially we have this formula. 48 equals 6 times D2 all over 2. Okay, remember this was a very similar situation to what we had with example 1 on page 17. In this situation, we multiplied both sides by 2. That's what we're going to do again. I'm going to multiply both sides by 2. I'm going to get 96 equals 6 times D2. Hopefully you notice at this point it is simple as just dividing both sides by 6. Let's see what we get. 96 divided by 6. You're going to get D2 equals 16 units. Okay, again, you can check your work real quick. So, by the way, this would have been what we're trying to find. Okay. Real quick, let me just show you how you would check your work. So if this is our formula, D1, D2, all over 2. Let's see how we can check our work. D1, we knew from the get-go was 6. D2, we just figured out was 16. Let's see that if we divide all that, or if we plug that in, 6 times 16 divided by 2, what do we get? We get 48. Okay, 48 was what it told us our area was, so we did it correctly. We're good to go. Okay, guys, y'all are going to do great. I know this looks like a lot, but once you start the homework, there's a lot of just plug and chug. I know they get kind of crazy. Remember, you have a squared plus b squared equals the Pythagorean theorem, and then also you might have to use trig, sine, cosine, tangent. It gets kind of crazy, guys. I didn't want to get into all those details in this video, but I'm sure your teacher can help you with tutoring as well. You got this. Have a great day.